Okay, this is Module 3, Lesson 11. Very similar to Lesson 10 and Lesson 9. Um, I'm going to solve this a little quicker because I'm assuming that anybody watching this would have watched the other ones first, so I don't want to be redundant, but the only real change here is the symbol, minus versus last time it was plus. If you're adding or subtracting, it really doesn't have a difference. It doesn't matter what you're doing when it's adding and subtracting because the process is exactly the same. So let's go ahead and find our least common denominator. 8, 16, whoops, that's a 6. 16, 24, 32. That should be high enough. Let's see. 4, 8, and it is. There it is, 8. 8 is on both sides. Okay. So this is the process for LCD, least common denominator, or least common multiple. It's interchangeable with that term. I wish somebody would just define it as 1 and be done with it, but that's just not how it works. Okay, so let's put an 8 over here and an 8 over here. I've noticed students over the years, when we get this far into a fraction unit with mixed numbers, I've seen many students, and it's every year, there's a bunch of them, and I never know when it's going to happen, but I see it almost one per day at this point in the whatever unit it is in with fractions. They start to do this in their head, and especially for this one, like 8 to 8, it's the same number. They know obviously it's times 1, and they don't want to do the arrows. They're just like, okay, well then that's 7, So that, it's good that they're getting it quickly, but they just got to be careful that they're not going too fast because fractions can be tricky. Let's go to green. Now 4 to 8, obviously that's super easy, just times 2. And then whatever I do to the bottom, I do to the top, always. So 3 turns into a 6. And we always review that these are equivalent fractions. 7/8 is equivalent to itself, of course, and then 3/4 is equivalent to 6/8. And I could double the top and bottom, and that would be equivalent too. It would just be different numbers, but mathematically it's the same. And to prove it, you could always say 6 divided by 8 on a calculator would equal the same decimal as 3 divided by 4, which would be 0.75. Let's see, equals, let's change colors here to blue. Now 8 is still on the bottom, and on the top, 7 by 6, 1. So after all that work, it's 1/8. 1/8 is the answer. Hard to guess that it would be 1/8 by looking at all these random numbers. I'm not going to solve this one here the same way, but I do want to show the number line version. Some of the questions, including letter H on this particular homework assignment, there we go, ask to show one of the questions on a number line. And it can be, for these kind of numbers, as a kid, it's kind of annoying to do that because you have to do a lot of drawing, but it can be incredibly useful. So I always tell the kids, do it. It might be a little bit obnoxious with all the lines, but the payout is great. You can really clearly see with these number lines, one of the better things that Common Core is good at, how exactly the fractions are working with each other. In this case, the function is subtraction. The toughest part, actually, is just setting it up. Now, if I'm starting at 1 3/10, just start it at something easy, at 2. That's above that number, and you're subtracting, so you're going that way. And you're only taking away a 1/6. You're not taking away a whole lot, so I would just go down to, maybe keep it simple, go to 0, and then have 1 in the middle. Whoops, oh, that's a terrible one. There we go. Now notice that denominators are different, so least common denominator of 60, if you multiplied it 60, that's a common denominator, but not the least. So 6, 12, 18, 24, 30, and 10, of course, goes into 30. So I'm not going to do that out, but it would equal 30. 10 to 30 would be times 3. The top times 3. 3 times 3 is 9. And there's a 1 in front of it. Yeah, just bring the 1 over. You don't have to worry about it. It's just trying to make it look confusing. And 30 in the bottom of the next fraction. To get to 30, 6 times 5 is 30, so 1 times 5 is 5. So there. Now this is what the subtraction looks like. This is what you should be drawing too. Let's use this green. 1 and 9/30. Now, you could draw 30 different slashes, but it helps to think about it in a more logical way. You don't have to be precise with this because it's not like they're going to get out a ruler and measure every line of yours, especially me. I'm doing it on a smartboard. It's really hard to do. There's no way I'm going to get 30 lines in here on the smartboard. So what you can do is say, well, what's half of 30? That would be 15. So 15/30 would be 1 and 15/30 would be right there. That kind of cuts it in half. So I'm at 9. Well, if 15 is there, half of 15 is 7.5. So let's just round it to 8 and go a little bit more than half. So 8/9 is a little bit more than half. Doesn't have to be perfect. So that means, sorry, not 8/9, 8/30. 8/30. And again, think of it as 1/30, 2/30, 3/30, 4/30, 5, 6, 7, 8/30, 9/30, 10/30, all the way to 15/30, and then 15, 16, 17, 18, 19, all the way to 30/30 would be right on 2. You could write them all out if you want, but that's it can be very obnoxious for most kids, and then they get frustrated. So, myself included, I get frustrated writing all those lines. So if you just use just basic number logic and your number sense to bring 15 in the middle, then half of that, roughly rounded up, is 8, and then 9 is right next to it. So here. And let's do the jump with red. So you're starting at 1 and 9/30, and you're jumping minus 5/30. So, well, 9, 8, 7, 6, 5, 4. So you're starting here and jumping to there. Notice I don't have to do below 4 because I'm not jumping to those. Minus, you're subtracting minus 5/30. So minus 5/30. 1, 2, 3, 4, 5. So the answer is 1 whole, and you landed on this one. Well, it's 9 minus 5 is 4, so this is 4/30. Obviously, it's tough to draw this to scale. It looks like it's on the 1/30, but it's really the 4, and then there's other lines here down to 1. So 1 and 4/30 is the answer. That's how you would draw it. But it's a little bit more clear when you're trying to visualize these numbers, especially with a fraction. Like, what does this look like if I tried to think about it? This is a good way of thinking about it and drawing it out. And again, it doesn't have to be exact. All right. I will see everyone hopefully tomorrow or the next day.